Three phases of a thunderstorm. Cumulus. Mature. Dissipating. And which is the most severe? What's always in the mature?
Updraft and downdraft.
What is it?
Updraft and downdraft.
Updraft, downdrafts, what else? Lightning. Good. What must you have for a thunderstorm to exist? Moisture. Instability. Lifting force. Good. Let's see. Who would like to describe in your own words what a front is? Angel.
It's when one type of weather takes over another one.
That's good. Called air mass. One air mass, definition of an air mass is a large body of air with consistent, similar temperature and moisture. And I always like to say, remember, temperature is relative. You can have in the northern part of our country right now, hi Tony, you can have in the northern part of our country right now a cold front approaching a warm front. The cold front is minus 15, let's see, let's make it realistic, 2 Celsius. The warm front is 10 Celsius. It's not going to happen that cold down here no matter what, thankfully. So temperature is relative. So now we have a cold front. So Nick, tell me a little bit about a cold front.
Well, I think it was like
Well.
I think it was like a medieval war battle. You got like a line of cold, and you got like a line of hot, and they're coming together in the field.
Yep, totally.
Battling out, and one will win over the other.
Yep. So in a cold front, which one is probably winning?
The cold.
Good. And what kind of weather will we probably expect on a cold front?
Cold.
Colder. Today we had a colder cold front come through. It's colder than yesterday. Up north, this would be warm. They'd be like running out in their swimsuits. You know, it's nasty. So a cold front. John, what kind of weather probably is in a cold front other than temperature change?
We have precipitation.
Good. What kind?
Shower and thunderstorms.
Thunderstorms? Serious precipitation, probably.
Yeah.
Showers, the word showers usually mean that pesty stuff that kind of gets you wet. So yes, very good. So significant weather, probably. Sometimes we have a mild cold front. Cold fronts move pretty quick. They're here and then they're gone. Christian, tell me about a warm front.
So a warm front, it's like a warm air mass that kind of pushes out the cold air. And
Good.
It's slower moving, and they're kind of bigger and less intense weather.
Good. What kind of visibility in a warm front?
Bad visibility.
Yeah. Scuzzy, pesty, you know, probably stratus, that drizzy rain. Probably not thunderstorms. Good. Okay, let's see. What was yesterday's topic also? Oh, I know. I'll give my favorite word to AJ, occluded.
I think there's a slow from eventually a cold's gonna
Beautiful.
take over the warm from what else would I don't know what that means.
Charades.
Not,
They're kind of mixed up.
okay. Oh, so that's
Yeah.
the temperature.
Yeah. You have the bad of the warm, the bad of the cold in occluded. And they're battling it out, but the weather kind of gets mixed up. So occluded. That's good. Let's see. Tony. Get your head out of the clouds. I could see you were flying. Tony, how about a stationary?
It's where warm and cold meet, and just there's no movement.
Yeah,
Just waiting
very
for
good.
one to take over the other.
Yep. How do you know which one's going to win?
How do you know which one?
It's a
Just
trick
about the
question.
type of weather that's created.
Good. That's very well answered, because it's a trick question. You don't. You just have to kind of wait and see. You kind of look at the pressure system, see if one's being pushed more than the other. You don't. It's a game. It's a guessing game. You can guess pretty darn good. Again, with stationary fronts, it's not moving. If you have a stronger one, it's going to win. Oftentimes, they're battling and they lose their energy. You know, the stationary front just kind of goes into stationary front. Heaven, I guess is the best way to say. Okay, so any questions before we move on to new topics? I think we pretty much reviewed yesterday. Oh no, fog. Yesterday was fog, right? Yep, yesterday was fog. Juan, what fog cannot survive in a wind?
Advocate.
Yes, I can. Yeah, 3 more tries. What fog goes up? Kurt, help him out. What fog goes up? Radiation. So, Juan, here's how your check rate's going to be. Tell me about advection. As soon as you mention something, your check airman's going to ask you about it. Advection. So now we know radiation fog goes up because at night the ground cools off quicker. If it is moist, it hits that warm air, picks up condensation nuclei, and you have fog. So now we have advection. What does advection fog mean? Sorta. Needs a breeze. Some kind of breeze. What else is advection fog? A breeze of what to what? That's fog. It's a breeze of something to something.
Sea to inland.
Good. So what is the sea's temperature?
Cold.
What cools off quicker
Uh,
at night? The sea or the land?
land.
Okay, so now we have probably sunrise. So you have a really warm sea. You have a breeze. You have that warm, moist air molecules picking up condensation nuclei, hits the cold land, you got fog. Okay, so it's a warm sea, moist air. Okay. Let's see. Let's wake Tony up again. How about upslope?
Upslope fog. It's when the air is moving up the mountain and it's cooling and it's condensing.
Very good. Very well said. Fog is really condensation. It doesn't matter if it's going up, going out, going in, it's condensation. It says moist air particles condensating on particles. And you have the temperature difference. That's very well said. So one more. Do I have a volunteer on one more? You got it?
I don't know.
Which one is it?
For what?
One more fog
One more.
that we haven't talked about.
Sea fog.
Mm-hmm. Sea smoke, steam fog, whatever you want to call it. How does that work?
It's over it's over a body of water.
It is. What kind of air is it?
Cooler than going in warms up.
There's one critical point of steam, fog, sea smoke,
Dry air.
dry air. You have that dry breeze, usually over a body of water. Body of water is generally warmer and certainly moist. And it's picking up that moist, warm. Hits the land, you got fog. Good.
Kind of similar to San Francisco.
Yeah. Then you add the smog. Yeah. Constant smog and fog in California, not just San Francisco. You go to California, have your instrument rating, you're not going to fly much. Okay, the topics remaining is not much, and they're easy. So we have basically 3 topics, and we go into services. PHEC 12-23, AIM Chapter 7 is great. So before we finish this up, I have your folder here already. What is your folder? So as it gets closer and closer to the 7th week, I put together a folder with information about your FA written, with each of your 290 papers, all ready for your 90s, with each of your endorsement done, and a copy of the fancy certificates, because it's on nice paper. So probably into next week, we'll go over to the testing center. And I know some of you after class, when we got out early, was in there practicing gliding. Good job. So, okay, so weather hazards. And thunderstorms, by the way, also is labeled as weather hazards. So we actually started weather hazards yesterday. Additional weather hazards. To me, most of these are kind of no-brainers. Turbulence. All number 7, 1 through 7 is listed as weather hazard turbulence. Mostly we talk about low-level turbulence, LLT. Low-level turbulence is defined as below 15,000 MSL. First one, mechanical. Obstructions on the ground. I put trees into mechanical because you have a runway. You come in on what will be runway 9 in Ormond Beach. Huge set of trees at the end of 9. And you're bumped up and down, up and down. Mechanical turbulence. You have a large hangar, you have a large facility of something, it's going to bump you up and down. As high as 3,000 AGL. Convective. I find convective is one of the more amazing, other than number 7. Glider pilots call them thermal. found this picture that's really a good visual on what a thermal is. So you have this moist pocket of air that's warm that goes up kind of like a bubble. And this is kind of what it looks like. And you have a horizontal wind. So you have these warm bubbles of air, and above the warm bubbles of air is a horizontal wind. This is how glider pilots fly. They glide from one pocket of hot air to another pocket of hot air to another pocket of hot air. And they use that horizontal wind and the heat that keeps them up there. So that's convective or thermal. Frontal, we now know, don't fly when a front pass. Especially a fast-moving cold front. Fast-moving cold front, you have those warm air molecules shooting up like crazy trying to get out of the way of that cold wedge going over. Possibly updrafts at 1,000 feet a minute. Those warm air molecules are going up. You're caught in them, you're trapped. Wake, we know wake turbulence. Air above and below the wing, at the back of the wing, moves outward, goes upward, and then goes down. Wake turbulence. Clear air. It was not that long ago that they actually understood clear air turbulence. Clear air, just like it sounds. You know, you have perfectly clear atmosphere, even like at 30,000 feet, you could have clear air turbulence. They discovered that two main reasons for clear air turbulence. Winds at altitudes. Winds at altitudes can be different speeds and different directions. When we look at winds and temperature aloft, and we learn how to read winds and temperature aloft, especially the last week. At 3,000, we've had winds from the northeast. At 6,000, we have winds from the west. Right in between there, we're going to have turbulence. Clear air turbulence. Doesn't matter if it's clear air or not. Then the jet stream. I'll show you how to look at the jet stream. Sometimes the jet stream, and that is located up near the tropopause. Sometimes that jet stream will start coming down to lower altitudes. Jet streams are significant winds. And it also is certain times of the year, it tends to come down. Mountain wave, I'll draw this on the board also. A pretty good picture, it's just kind of tiny. This is the leeward side of a mountain. So you have stable air over the top of a mountain sometimes. What happens is that it starts picking up speed coming down the side of the mountain, and it flows in a layer. Could be like frontal, 1,000 feet a minute, sometimes up to 3,000 feet a minute. You're going to get smashed into the side of the mountain. You're not getting out. And it'll be in waves. There are two clouds on the other side of a mountain that tells you if you have this going on. And one of them, and this is on your phase exam. So you have this mountain thing going on. You have stable, calm air that shoots down the side of the mountain, picks up speed significantly. If you have this going on, one of the clouds is called a lenticular. Basically, it's about this shape. think it's the A. Oh, yeah, they don't have it on here. Lenticular. We nickname it the eyebrow cloud. On your exam, it's going to be lenticular. But we nickname it an eyebrow cloud because it looks like an eyebrow. It's right about this distance from the mountain. Then right about here, you're going to have a rotor cloud. Usually you have them both. Sometimes you can, when I did mountain flying, mostly I saw lenticular, but you can have them both. Avoid the mountain. Go miles out of your way if you have to, because you're not getting out. Inside these clouds, you can have winds greater than 100 knots. They look like they're standing still, but they're rotating like crazy, and it rotates out this way. So you have this action going on, and you have these rotating clouds. Mountain waves. I can never remember the name of the famous record breaker that was flying a Husky and thought that he was just like super macho, and he's doing mountain flying and got stuck in a mountain wave, smashed into the side of the mountain. It took him like 3 months to even find him. They were picking up pieces. You're not getting out. In your career, you're flying way over these mountains. It's not an issue. If you get your private pilot, your instrument, your commercial, whatever, and you decide to go fly a general aviation airplane in the mountains, you should take a mountain course. Wind shear. Wind shear, question on your written and maybe a phase exam, happens at any altitude. Do not fly when a front passes. Generally, it's frontal. The danger of a wind shear, any altitude, usually you can't see it. Also, temperature inversion. You know, you have this warm layer right here, can have a warm layer at altitude. What happens is that you're flying along, all of a sudden you have a headwind. You go, holy crap, I'm losing altitude, I'm going slower. You give it full power. Right here, you're going to be pushed down. Doesn't matter how much power you have, you're being pushed down. You make it through this part, now you have a tailwind. And all of a sudden you have full power. You're probably ripping your airplane apart. So the danger is you have a headwind, then you have a total downwind, then you have a tailwind. Called microburst, the worst wind shear. This is a real short video. It's amazing.
The convective turbulence is the same that the gliders use to burn them. Yes.
Mm-hmm. Yeah, it's the glider's power.
Okay.
Thermals are exactly what gliders do. Yeah, it's pretty amazing. I've done a little bit of glider flying. You know, just a little bit enough to say that's amazing, but not understand how they know that. You know, it's amazing.
We had some kind of specific clouds when I have a thermal.
Cumulus. It's the cumulus clouds. Yeah, you fly underneath the cumulus clouds. You know, you have this heat thing going up from the ground, and once it hits that cooler air, you have the condensation nuclei and those moist air molecules picking up, and you have a cumulus. Glider pilots love cumulus. We don't like cumulus. They bump us around.
When I made the skydiving, my instructor said, don't open your parachute over this kind of
Cumulus.
cumulus.
Above and below.
Up, down.
Totally. It's amazing. You fly, you know, you keep your VFR distance, 500 feet below cumulus cloud, even 500 feet. If it's a serious cumulus cloud, you're going to be sucked up. You know, enough energy that, you know, you can control it, but you're going to feel that. Okay, so let's watch the video on microbursts. This is really, I don't know how the photographer captured this. It's called a wet microburst. You usually do not see microbursts. They're clear. You know, it's just air that is giving you a headwind, pushing you down, and then all of a sudden a tailwind. But this is really rare wet microburst. It's a good visual on what's happening out there when you don't see it.
Photographer of Monsoon Chaser, Brian Snyder, was taking time-lapse footage of a storm in the Tucson area when he captured this incredible weather event, a wet microburst. Microbursts affect an area of no more than 2.5 miles across, and they occur when a cooled, heavier column of air sinks rapidly in the middle of a thunderstorm. As the air hits the ground, it spreads out with great force, often generating winds of over 150 miles per hour. In the case of a wet microburst, it also brings crashing rain, often described as a rain bomb. Thunderstorms are frequent and quickly forming at this time of year in Arizona, but to capture a microburst so vividly was a special event.
So regular microbursts, you don't see it, but that's the power that you could be caught in. Fronts, temperature inversions. So I want to make sure I'm not missing anything here for you. This is definitely common sense. Restriction to visibility. Definitions. Haze. Definition of haze is fine, dry particles in the air. So it's hazy out there. What you're saying is that we have fine, dry particles in the air. Smoke. Combustion particles in the air. The country India has combustion particles in the air all the way up to like 11,000 feet. Lots of combustion. Smoke. Smog. Here's your California, San Francisco. Smog is a combination of fog and smoke. They have smog. Dust, soil particles, serious dust storms in the arid countries. Volcanic ash. As I shared with all of you earlier on in our lessons, volcanic ash can travel thousands of miles, very high. The jet stream can pick up volcanic ash and travel it all the way across the country. So volcanic ash is filled with gases, dust, and ash. The worst of volcanic ash is the poor visibility, and it can clog up your engines. Very little on tornadoes. Tornadoes described as spinning columns of air descending from the base of a funnel cloud. Winds in a tornado could be over 200 knots, hail at all altitudes, severe turbulence, and possibly wind shear. Final weather hazard. We briefly talked about ice in frost and aerodynamics. Kind of a refresher. Ice happens at altitude, frost happens on the ground. They both do the same thing, but they're both created in different ways. Frost and ice causes a loss of lift and an increase in drag, interferes with the smooth airflow over the wing, increases stall speed, reduces performance. Remember, you're looking at indicated airspeed. Increases stall speeds. To have ice, you must have visible moisture. It can be in the form of vapor. Most clouds hold visible moisture. Definition of frost: temperature of the surface area at or below dew point. So what's dew point? The actual moisture in the air. So now you have a cold wing, moist air, possibly could develop frost. A tiny, tiny little layer of frost is going to do everything that you see on those 3 bullets. One of your FAA questions about ice and frost is, does it change the aerodynamics of a wing? No. That FAA question indicates that you're actually physically changing the aerodynamics of that wing. No. It's not the correct answer. You are having a loss of lift, which increases drag. You're interfering the smooth airflow over that wing. You're not changing the aerodynamics of it. You're increasing your stall, which is also going to reduce your performance. You can see some eyebrows going, what? To change the aerodynamics of your wing, you physically have to change it. Three different basic types of ice. I've had them all 3 on the citation. I actually had rime ice on my horizontal stabilizer, once on my Grumman. It was not a good moment. Rime ice, brittle, frost-like, breaks off pretty easy. Clear ice, really hard, really difficult to break off, kind of shiny. They say it's difficult to see, but I could always see it. It's pretty shiny. Mixed ice is a combination. Usually it's kind of easy to break off. Clear ice is hard to break off. Remember, ice is in the clouds or in the air. You have 2 different types of icing systems. You got to just be familiar with them. When you get in your instrument, you have to know the details of how they work. You have de-ice. After the ice forms, you got to get rid of it. Anti-ice to help prevent it. Some of them are crossover. We fly airplanes that are not legal to fly in icing conditions. You get in your career, it's legal to fly in icing conditions. If you have a carburetor, you have carburetor heat. That prevents the ice. Pitot tube prevents and can melt the ice. Heated windshield. Heated windshield is usually described as an electronic like a car, can have a heated windshield. It's electronic wires through the windshield. Pneumatic boots, the Citation had them, they're incredible. Pneumatic boots is a rubber boot that fits over the leading edge of an airplane. It'll be another V-speed that you'll have to memorize, and you're only allowed to hold the button, because it's usually a button, for so long. And you're only allowed to do it, like, I think the Citation was 3 times. And what happens is the boot expands and breaks the ice off. Very effective. Alcohol or electric propeller or wing. The Cirrus had an alcohol wing and alcohol propeller. The Citation had an electric wing. Just like it sounds, it has electric elements. The Cirrus had the alcohol propeller and wing. They call it a weeping wing. It's tiny little pinholes along a wing. You push a button, it's usually de-ice fluid. Just by simple aerodynamics, it spreads across the wing and melts, pretty good at melting it. With a propeller, alcohol propeller, it's about the size of a baby finger that pokes out from the hub of a propeller. You push a button, that de-ice fluid just spreads out by aerodynamics and melts the ice on the propeller. Let your brains take a break. Did we have some early flying? No early flying today. You might have had to be here early, but it wasn't going to be happening. Who flies tomorrow? Are you on yet? It'll be gorgeous tomorrow. It's going to be a beautiful day.
6:30.
What time?
6:30.
Oh, that's awful. It's awful. It's going to be beautiful. Yeah. Oh, that's awful. Oh. Well, tomorrow we finishing up weather services. Probably finish early, so you'll be able to take a nap. Ooh, my airplane today just went in annual, so it's like I was hoping they'd wait till Friday. And it's like, oh, beautiful day. Get it done though. No flying tomorrow for me. Okay, so ready for services? We'll probably cover maybe 2 of the services, take a break and come back and cover some more. These are the services or the products that we need to cover. Right now, we're really laying the foundation for when you get in your instrument. We're laying the foundation as a private pilot, being safe, knowing how to forecast the weather. Then when you get in your instrument, you really need to know in detail. We have observed weather products. We're going to talk about each one of these in detail. We'll probably go up to PIREPS and take a break. Observed is 2 ways, human observed and computer observed. Forecast. Meteorologists are using computers and they're putting all their magic together and they're forecasting what it could be. And hazardous. And we will be, after each of the services we talk about, we're going to aviationweather.gov. As a matter of fact, that's got to be your main homework tonight. Poke around on if you have not. I think most of you probably have. If you're flying, your flight instructor is taking you there and said, okay, now it's your turn, you got to do it. The only way to really know weather is to poke around on the weather site. I start with METARS. Aviation Routine Weather Report, METARS. Because when you know how to read the weather language of a METAR, you pretty much know how to read the weather language. Especially international students. I really respect that you guys are able to come over here and talk our language. So when you learn weather, it's pretty similar, a little easier than learning another language. So when we talk weather, you need to know the definition of a ceiling. Above ground level, not MSL, AGL, height of the lowest layer of clouds reported as broken, overcast, or vertical visibility obscured. Up and down, vertical visibility obscured. Broken and overcast. So when we see broken or overcast in a weather report, let's see, let's erase our mountain. Have a cloud. We will have John flying. This is John flying. Here's a cloud. This cloud is occasional. You see occasional in a weather report. If you can remain the visibility and the distance from this cloud, you can fly. You're a VFR pilot. So now, we add broken around John. Let's see, we have to do a little more. John cannot remain out of the clouds. He's a VFR pilot. That's broken. Overcast. Certainly can't fly. If, let's see, let's make a different color of an airport. We have an airport. We're going to have April, her favorite color. April is 10 feet, MSL, taken off, New Smyrna. We have weather reporting, broken and overcast. April can remain clear of those clouds, even though it's reporting broken or overcast. If you have scattered, and that darn cloud is right over April wanting to take off, can't remain clear of that cloud. So not only broken or overcast, but where in the heck that cloud is and can you remain the distance. Have a high overcast, who cares? So let's read a METAR. Probably one of the hardest things to do is memorize when these are released. You gotta know it. Definitely a check ride question. All your weather services, you have to know when they come out and how long they're good for. I have handouts. Hopefully something's going to help you. METARs come out 45 to 55 minutes past the hour. New Smyrna, I think, is like Ormond. Pretty much it's always 47 minutes past the hour. That's important because if we check METARs now, look at the time. It's pretty old. A lot can happen in that time. So to read a METAR, I made this one up. I think I changed it so it finally makes sense. So type a report. If it doesn't have speci, it came out 45 to 55 minutes past the hour. If it has speci, something significant changed. It could be for the better or it could not be. Station identifier, MLB. So I have Melbourne. Type of report, so now we have the date, or the first two numbers, and the time. So I made it up on December 2050. Pretty late. Wind information. All your winds on weather except for one report is in true north. So just remember, true north except for one that we'll talk about. So now the wind information in true north, 080, 20 knots, gust to 38. Visibility, statured miles. Most of weather is statured miles. How far can you actually see? Half a statured miles, pretty sucky day. Then they're going to have qualifiers if there's anything that's a qualifier. So what do we have here? I know Kurt knows weather. What about this? Increasing. Not getting better. We'd hope if we were looking at this it'd be a minus, but with this bad of weather it's going to be a while before it starts decreasing. So qualifier or descriptor might not have anything there. Then they call it weather phenomena. What's happening? Fog, baby rain, we call BR baby rain, mist. I have a handout on all the abbreviations that are critical to know right now. Sky condition, now we go back up to ceiling. Here we have scattered, add 2 zeros, 800. So if it's scattered at 800 at 10 feet MSL, if we have it right over the airport, we can't do it. Overcast, 1200. CB, who knows what CB is? AJ, what's CB? Yeah, it doesn't, I don't know why they pick CV, it doesn't make sense. Do you know, Christian? Nope.
I would guess cumulonimbus.
That's it, cumulonimbus. CB, cumulonimbus. The C makes sense, what's B mean? I don't know. So we have overcast 1200, cumulonimbus. Temperature in Celsius, 20. So I'm right here. Dew point, 18. So our air is almost totally saturated because we only have 2% remaining that we can cram moist air molecules in. Altimeter, 2995, so slightly above standard. Remarks is probably the most difficult because they still throw things in here that I go, what? And I have to look it up. Rain began 24 minutes after the hour. That's kind of a typical one. Then we put in sea level pressure. This is easier for me than yesterday when we were trying to do the math. 1013.4. in millibars. We look here on the pressure, and sure, you know, they match. You can have at a class Charlie and a class Bravo in a METAR A01 or A02. These are that Charlie or Bravo has very specific reporting on temperature and the amount of moisture. Let's see, how do I want to say that? Temperature to the detail and the coverage. AL1 gives you only the temperature to the minute agonizing detail. AO2 will give you the temperature to the detail and the coverage. We'll look at Daytona Beach and you'll see that the temperature is like agonizingly minute. I don't want to go there. I want to start at the beginning. So, observed METARs. We're not going to look at TAFs yet. I know those of you that have been poking the website know that Daytona has a TAF. We're only looking at Daytona's METARs. So we went to observed. We're talking about observed products. Come down here. KDAB. I want to go to DAB because I want to show you the AO1. So we have Daytona Beach. 13th day. Let me increase this. Starting tomorrow, I have all of you read it. I'll pick. "13th day, 1953 Zulu." So how old is this? Pretty old. Almost 30 minutes old. A lot can happen in weather. It's Zulu. We know now that it comes out 45 to 55 minutes past the hour. So another one's going to come out in 20 minutes. Got it, John? 1953 Zulu. Okay. Well, it came out at 1953 Zulu, so that was 35 minutes ago almost. I'm betting that Daytona Beach probably comes out at 53 minutes past the hour all the time, so the next one will be 2053. Like New Smyrna, pretty consistent, 47 minutes past the hour. We look at New Smyrna, it's probably 1947. The next one's due out 2047. Kurt's nodding his head. Most deltas, it's right around 47 minutes. So now we have the wind. 360 at 9 knots. Not bad. Not bad at all. 10 statured miles. Are winds magnetic or true? True. Statured miles. A few, add 2 zeros, 2,400. A few is a wisp here, a wisp there. Overcast at, add 2 zeros. I can't say it in my brain without writing it down. Isn't that pathetic? What is it, Kurt? 13,000. Overcast. It's a pretty high overcast. You can do an awful lot of maneuvers in between there. We don't even have this cloud. That's up here. Temperature 14 Celsius, dew 0.8. Wow, it's dry. A lot of room there for moist air molecules. Altimeter 30.09. So, John, do we have a high pressure or low pressure out there? By just looking at the altimeter, can you tell me, do we have a high pressure or low pressure? Here's the first thing to think of. What's standard barometric pressure at sea level? Standard on a standard day is 29.92. So now if we have 30, is that higher or lower? So what do we have, a high or a low? We have a high pressure. Is that a good thing or not? Usually it's a good thing. Remarks. There's our AO2. So we go over here. We look temperature, 14 Celsius. 14 Celsius, the exact temperature. It's a meteorologist thing. We don't really care. The exact temperature to the detail. Then we have sea level pressure. So sea level pressure, 10 in millibars. This is millibars. What is it? That is a high pressure. That's how you read a meter. They'll throw in weird things in the remarks. So does anyone know in remarks a dollar sign? I had to look this one up years ago.
That the way the meter comes out needs like maintenance or something.
It's it. Again, a meteorologist, I think all meteorologists must have sense of humor. It's because someone said when I finally went, what that mean? That a meteorologist's sense of humor said it's going to cost a lot to fix that. So yeah, something's not right. They're not reporting it right. So I don't know if your flight instructor showed you, but try not to do this if you can at all help it. If you get stuck, the easiest way to read weather is to go in here. If you get stuck, all except remarks, you can decode. Remarks you're going to have to look up. And right here's everything we just went through. But if you get addicted to this, you're not really going to know how to read it.
So what exactly is the AO1 or AO2 again?
That's the reporting equipment that Class Charlie or Class Bravo has. And it's just temperature to the dew point. AO2 has additional reporting. You know, all you need to know as a private pilot is that it is a reporting equipment that a Charlie or a Delta has, and it's temperature to the detail. I have to remember exactly what it is so I can answer you. I'll find it during break somewhere in here. I have it written down exactly what it is. If you're really interested, I have a handout that explains it. Sometimes I have students really wanting you to know. One more, then we take a break. Study Buddies today is going to be Gleim Unit 8.3. best way to know how to read a METAR is to read the GLIME questions. METARs are a little different on language from, or PIREPs from METARs and TAFs. METARs and TAFs have the same language. PIREPs are a little different. And these are all the METAR questions. Sorry, PIREP questions. Pilot weather reporting, they're great. It's really what's happening out there. Air traffic controllers, flight service, everyone loves PIREPs because pilots don't do them enough. I do them all the time. Mostly what I do them on is overcast, few. You know, when I'm flying, sometimes they're reporting a few and it might be broken, might be scattered. So I'll do a PIREP that, you know what, it's really scattered and it's really at 800 instead of 1,000. Again, how do you know the height of a cloud? Part of it is experience. You're taking off almost at sea level. You climb out, there's a cloud right there. You're at traffic pattern altitude, 800. That starts your concept of where 800 is. So it's really experience. So PIREPs, pilot weather reporting. This is the way when you call in a PIREP they prefer. I can tell you from experience, they love PIREPs. They're going to accept anything you give them at a PIREP. I'll tell you what's really important for them. Let's go through what it is. If you are reading a PIREP, the controller that you're reporting to is either going to do a UA or UUA. When you're reading it, if it's a UA, it's a routine. Someone like me is out there doing a cloud report. UUA will be turbulence. So location from the navigation aid. So you would report from Ormond Beach VOR. So November XYZ, I'm just going to make it up, 10 miles southwest of OMN. The time in Zulu, 1950 Zulu. Let's just say you're really busy and you didn't have a chance to call this PIREP in and you really want to do it. So you can say whenever you have the opportunity to call up the controlling agency, say I'd like to do a PIREP from OMN, and let's just say it was at 1650, and it's now 1950. So we'd say 1650 Zulu. Altitude's really important. So we are November XYZ, 10 miles southwest of Ormond Beach. At 1650 Zulu, I experienced at 3,000 feet. Aircraft type is really important. Turbulence to us in our 172 to turbulence to King Air is huge, huge difference. So they really want to know the aircraft type. Cessna 172. After that, anything that you have to report. If you're reporting sky cover, that's all you give. Visibility, I do visibility also. Because sometimes I'll be reporting 7 miles, and I'll say, it's more like 5. You have student pilots out there, they don't like 5. 7 miles, I mean, 7 miles is fine. 5 is getting a little low. Temperature, for us, we don't care. Wind speed, direction, turbulence is a big one. Icing is another big one. In your career, these are big ones. and anything else you want to report. Here's the way it's going to read. It's a little different than METARs or TAFs. It makes sense if you understand what it means. So you're reporting from the navigation aid. If you're south, it's going to be Melbourne. They have a VOR. If it's northwest, it's probably going to be something like Gainesville VOR. And you just give your distance. So now the controller will put in the closest airport you're reporting from. If it's Ormond Beach, it's probably going to be New Smyrna. It's a routine, so it's UA. Then it's going to read over the navigation aid you're reporting from. So over OMN, this one is Appleton, and the location from that VOR. So over Appleton, and it was, let's see, 10 miles, so 10 miles, 230 from it, 10 miles, so 10 miles. TM, that's an easy one at the time. 1560 Zulu. FL, this is a form. They can't change it to just altitude, so it's always FL, flight level. So it doesn't matter. At this particular one, it's 8,500. For us, it'll be something like 3,000 or 1,000 or something. TP, type of plane. So again, it kind of makes sense. UA, routine, UUA, special. Over what VOR and where you are to that VOR. Time, TM. Flight level, altitude. TP, type of aircraft. This is Beech Super King Air. Sky condition, SK, makes sense. Sky condition is broken, 6,500. Any kind of weather phenomena. Let's see, so we have haze and FU. Everyone loves FU, that's smoke. And this is where it's from. 3 statured miles. Flight visibility, 3 statured miles, haze and smoke. Temperature, if you have it. Turbulence, if that's what you're reporting. There's light, moderate, heavy. So let's see if we have any. We probably have a few. Were you looking? I have the direct links on the PowerPoint if you want to do it, but I prefer to go from the starting point so you know. We're still observed. My preference, let's make it small for when I get into some of the weird reports like PIREPs, I go to Tools, Standard Briefing. All your services are here. Well, except for like hurricane and a few other really weird ones. So let's scroll down. Right here's a PIREP. Scroll down. Gotta remember, I thought it was Miami. Let's go KEVB. Sure, we'll go 200 stature miles. Oh, we do. Look at, we have all UAs. So we went 200 statured miles. LAL is Lakeland. PIE is St. Pete, thank you. Gainesville. SFB, I believe, is Sanford. And then Titusville. So it's good. So we have a whole range here. So we have UA over, you can see it's over the VORs. Then it tells you the distance from the VORs. time, just recently. Does everyone see where I'm getting at? The best way to know them is to read them. So let's see what type of airplane. That's usually my favorite. A319, A319. Oh, he did all of them. 321. No, wait a minute. Yeah, TP. Pilatus. I think that's a Pilatus. I love Pilatus. C525. Here's a Cessna 172. God love them. Look at that. Titusville. Very good. Let's see what he's reporting. Overcast at 2,000. That's really great. The only way to do it is to read them. So this guy was really reporting light turbulence, occasional moderate chop. This airplane for us, it is probably more than moderate chop and light turbulence. That's why it's important. Can't remember if we have a decode on this one or not. Yes. So just make darn sure that you know how to read them. And they give more here. Here's a Jacksonville one, 737. 10,000 moderate turbulence, so that front is finally moving through. They're kind of fun to look at. Yeah, the AIMS 7-1 is really good on PIREPs. It gives you the way that they want you to report it and everything, but again, you give them the critical stuff and they're happy. So you dial up or you talk to whatever controlling agency you're talking to. Oftentimes I'm on Ormond Tower, and I'll tell them I'm going to do a PIREP. I don't have to tell them Ormond VOR, but being a good pilot, Ormond VOR, where I am from Ormond VOR, they know my voice, but I tell them AA1A, and then I give them whatever else I'm going to do. Okay, what do we want to cover here? Let's see, let's do as much as of observed as we can. Let's go till 4:30, then we'll do study buddies till 4:45. Can you handle it?
Let you know when I wake up in the morning.
Okay. So I have handouts. We'll have to remember for Seth also. Put a little Seth pile here. Because now we're going to talk about, this is what's on this slide. On the back is a product, a weather service that we're going to talk about. Right now we're going to talk about this. This is the weather services we're talking about. And Embry-Riddle had a great back-to-back one-pager. It was very dated. If you're studying the Embry-Riddle one, don't study it. When I first started here, I was using it, and then the weather services and products changed immensely about a year and a half ago. So what I did is I took the weather product or service, I put a graphic to it of what it is. I put on each one that has a start time and when it's no longer valid. So all your services that we're talking about is on this stapled handout. Hopefully it helps you. Remember, when these products are released, 45 to 55 minutes past the hour is what you need to know also. TAFs are probably the hardest. I'll break it down. TAFs, at least for me, were. So I get a little pile for Seth. Everyone get a back-to-back single page, then let me know if you get a staple. They stapled kind of goofy from the copy machine. METARS is on there, Pyreps is on there. Pyreps are valid at the time of reporting. So this is observed and forecast when we get into forecast services. These are all the abbreviations and the images that you need to know, including your instrument, including your commercial, including your career. What you need to know now, this, and what I have put a blue bracket on for abbreviations. That's the most common of what you're going to get. When you get further on, you need to know it all. So let's look at what it is. This is the wind. You're flying, let's see, you're flying this way. So you're starting at the tail, flying to the arrow to the lines. The flag is 50 knots. Each full line is 10 knots. Half a line is 5 knots. If you have a red line, that's a gust. You can have a red 5 knot, or you can have a red 10 knot. Or you can have all these red. It's a gust. So this is 50, 60, 75 knots from the west. So you're flying that way. And the wind is that way. This one is 1025. The wind is coming from the northeast. Got it, John? Calm, a pathetic 5 knots. So you're flying from the flag or the line down the tail. This is a little more information. You still have a wind barb. We call them a wind barb. B-A-R-B. Temperature in Fahrenheit. Dew point. Whatever weather symbol you might have. Look on this one. We have 3 dots. We have some significant rain. Clear. Current sea level pressure, 1010.7. The pressure trend, it's going down 6. millibars. So it's starting, the pressure is lowering, not a good thing. Then you have what could be included in the circle. When you get in your instrument, you need to know the exact percentage. Your questions will be pretty, as a private pilot on your exam and your phase exams, you know, a quarter of the sky is got some cloud cover. Your instrument, you need to know 25%. That's easy. 50%, 75%. Overcast. Obscured. What does obscured mean? Can't see. Totally obscured. It's like nothing out there. And then the M for missing. These symbols, once you really know what they are, make sense. We call them hats. Hats are turbulence. The more hats you have on top of each other, the more severe the turbulence. Icing is a U with lines. The more lines you have, the more severe the ice is. And then, of course, rain is a dot, snow is a flake. Drizzle, that tiny misty stuff, has a tail. A shower, constant, pesty, some precipitation. Now we have a rain shower. We have a dot and a triangle. I think of them as an ice cream cone. An ice cream cone. Snow shower. Thunderstorm. Freezing rain. You won't see this too often. A tropical storm. We will be seeing that. Hurricane, typhoon. We will be seeing that. Hurricane. Yeah, typhoon is a hurricane on a different part of the world. Abbreviations, again, these are the ones you really need to know. I had to look up, what the hell is it? What the heck is the difference between GS and GR? Small amount of hail, great amount of hail. GR is greater. GS is smaller. Baby hail. I don't know.
Well, I was trying to figure out how you got urban area, CIT.
City.
City?
I'm trying to see which one you're talking about.
Up on the top. I guess
City.
City.
I think some of them use French. Like I know, I think Nice
Yes.
is, at least that was French.
That's very good, Tony. Let's see, where's mist?
That's what it's
BR, baby rain. This time of year we get a lot of baby rain. Yeah, mist on our windshields, especially if you, like me, you don't have any kind of defrost or anything, it's a bad day. We get a lot of mist. Most students' favorite is FU. So those are the important ones.
I just remember the Spanish word for smoke. Fumar.
What, it's Spanish for smoke?
Fumar.
Mart?
No.
Fumar.
Fuma. So it's Spanish.
Yes.
Oh. To me, smoking is definitely FU. Anyway, inappropriate, cut that mic. I thought I had one more, but I guess not. Let's see. Still observed. Trying to decide how much more information I want to put in your brains. Two different types of radar reports. The basic radar weather report is updated as it happens. That's generally what we look at. Important on your written, what does a radar report show? It shows areas of precipitation, type of precipitation, intensity, location, direction, and speed. This is all the radar weather reports, doesn't matter which kind you're looking at. I'm trying to remember what the question throws in there for an answer, and it's not correct. Oh, trend. It does not show trend. You think it does because you're seeing the movement, but it does not. So now we have the as it's happening weather. We have a radar summary that's come out every hour. This is what it looks like. We'll go find it on the website. And you can see now we're flying this way. This is not live. 10:25, so 25 knots from the west. So this is updated every hour. I don't know why someone would look at it, but I suppose some people like it. We're still observed. Remember, as observed is a person and a computer. So we're under the Observed tab. Come on. Radar. This is as it's happening. Whew. Lots of stuff blowing us down to the southeast. That's a radar report. For summary, updated every hour, I go to Tools, Standard Briefing. Let's see. Surface analysis, weather depiction. Nope, we're right here. That's updated every hour. You have your wind barbs, you have your direction. So let's see, how many wind barbs is that down there? 10, 20, 35. 35 knots at 240. Again, observe product, and I find it under Tools. We'll call it a day after this one. No, we'll finish observed because they're not that hard. Surface analysis. On the back of your single page, what I did is I put a surface analysis and put this larger. You probably on your written will not get any surface analysis questions. Probably on your check write. I call them ugly charts. There's so much color and information on those charts, it just like my brain melts. You gotta know what all those colors mean. Surface analysis, you also have to know it's updated every 3 hours. Surface analysis shows you atmospheric pressure patterns, high and low pressure in fronts. Let's see. Yeah, we'll look at surface analysis and we'll talk about satellite weather. Surface analysis, I go to Tools, Standard Briefing, down to Ugly Chart. Are you ready? It's ugly. Yeah, wow. It's on the back of that single page handout. For me, it's way too much information. If your mind can break it down, you have a lot of information here, all on one slide. It like hurts me. You gotta know what the colors are, you gotta know all of it. Every 3 hours this is updated. 3 hours is a long time in the weather world. So you can see we have pressure, millibars. We have the cold front that just slipped off. We have temperature and dew point. We have our wind barbs. We have obscured. We have heavy rain, temperature, dew point, our isobars. So we got a lot of information smashed here. Surface analysis. All those colors mean something. Every 3 hours. So 18 Zulu is when this came out. Everyone see that down at the bottom? 18 Zulu.
And it's good, but it's not centralized.
You what?
To me, it's not like centralized to say your general aviation unit where you're flying, you know what I mean?
Yeah.
So it's kind of like,
For me, it's every 3 hours. That's a long time for weather.
yeah.
If you hit it right when it's released and your brain can deal with all that color and know what you're looking at, that's good.
And radar.
Yeah.
This is like old school.
It is old school. Well said.
Should be taken out. But, you know how the government.
They didn't ask us. Anyway. Satellite weather. Satellite weather can tell you more than radar. I usually look at radar, then I look at satellite weather. Satellite weather is updated every 30 minutes. Satellite weather shows you clouds. And they say texture, the water content in those clouds. It is not precipitation, but it can tell you a lot. So first let's look at, make this smaller. So it's still observed product. Let's first look at radar, and then we'll look at satellite and see what it's really telling us. So now we have a whole lot of rain down off the Keys of Florida, covering the Keys over Miami. The green is it's rain. The yellow is it's heavy. The red is it's seriously heavy. We have little pockets of red, a lot of rain. Probably 1 dot, 2 dots, and a little bit of 3 dots if you're looking at your other charts. So now let's look at satellite. Remembering this precipitation is what you're looking at. The type, it blue up there, thank goodness we're not up there, blue and gray, that's frozen precipitation. So type, movement. Observed, satellite. Whole lot of moisture over us. And it's fairly thick. We have a whole lot coming towards us. And it's moving pretty quick. This really can tell you a lot. So look at radar, then look at satellite.
It's updated every 30 minutes.
30 minutes.
But what's the range of that movie?
Oh, good question. Meaning, when was it released? To me, it is live, but they say, okay, right here.
Oh,
No, let's see.
3 hours.
There you go. So it's ticking down.
3 hours.
Wednesday at
Yeah.
2019. 13th, Wednesday, 2019. That's a great question, Juan. I've never had that asked. Again, you're my favorite guy. You think through things. One more, and we'll do study buddies. Because then we finish observed. Tomorrow we'll review all this. We review it by actually looking at it. Depiction, not quite as ugly as the surface analysis. Not one of my favorites, but it's still pretty helpful. Weather depiction chart, every 3 hours, long time in the weather world. Your question on your written could be, what does a weather depiction show you? I underlined the correct answer. A general overview. That's the correct answer. Weather depiction shows you a general overview. And it comes from METARs. So for me, why not look at a METAR that's updated every hour? This is every 3 hours. But again, they didn't ask me. Weather depictions show you restricted visibility and ceilings. Kind of easy to read. It's not as bad as the ugly chart. The good news is that when you get your supplement guide for your written, the answers are right there in the supplement section. Go to figure or whatever it happens to be. You're going to be given the area of the United States. What figure do you look for? 27. Go to 27, a time zone question, and it lists all the United States states. So it's probably going to be something like in the state of Oregon, in the state of Utah, in the state of Texas. Don't know. Go to figure 27, find where they're talking about, where you need to go and look on that chart. Go look on the chart. Right here is what's going to be on the figure for weather depiction. It gives you the answer. I just put it out in big. Gives you the answers. So if it's IFR, it's right down here. Ceilings less than 1,000 or visibility less than 3 statured miles. You're going to have the hatched. It's going to be some kind of contour line with hatched. If it's marginal VFR, ceilings 1,000 to 3,000 or visibility 3 to 5 miles, you're just going to have an outline. Right here is marginal. Right here is IFR. You don't have any line, it's VFR. Right here tells you exactly what they want for VFR. You also have your little circles. But your question is going to be more on what is the visibility in Utah. Go to figure 27 to find out where the heck Utah is and go back to your weather depiction figure. They love Texas. They love Texas, they love Oregon, they love Utah. They love the weather depiction chart. Shows a general overview every 3 hours. So we'll look at it, then we'll do study buddies, we'll call it a day. Because then we go into forecast. Weather depiction. I go to tools, standard briefing. Surface analysis. Oh, shoot. We want weather depiction. Come on, you're my first officer, so I'm getting tired. You gotta keep me on track. So, weather depiction. Right here is going to be an example of what you have on your figure. Look here. Look wherever the heck they're going to place you on this map. Go to figure 27 to find out where they just placed you. So let's just use Florida as an example. We have IFR right here. We have marginal VFR. We don't have any lines. Good visibility. We still have some cloud cover here. 2 zeros. Oh yeah, we have it 3/4. 20,000. So that's pretty high though. Thunderstorm symbol. Rains. Remember I said that's probably 1 dot? Well, we have 2 dots, 3 dots. How often is this updated? Every 3 hours. Let's see if we can find when it's out. 19Z. It's pretty old. Okay, so tomorrow we'll finish up services. We have forecasts and we have hazardous.